In this video, we're going to calculate the discrete time Fourier transform of the following given signal. Remember that we did the type 1 signal, which was symmetrical about the central element. Type 2 was symmetrical but did not have a central element. And type 3, which is the one that we're dealing with here, has a central element that is equal to 0, and it is antisymmetric about that central element. So I'm going to begin by writing the equation for the DTFT. It's the summation of n goes from minus infinity to positive infinity, x of n times e to the minus j w n. So we're going to fill in with the coefficients that we know. So that would be 23 e to the minus j w 12 plus 0 plus, or rather minus 23 e to the j minus j w 14. So here we should have e to the minus j w 13, but it's multiplied by 0, so it's not there. So the trick here is to take out the common factor and also take out e to the minus jw13 as if it was there. So really what that is 23 e to the minus jw13 times e to the jw minus e to the minus jw. And what you'll recognize is that that is equal to 23 e to the minus jw13 times 2j sine omega. Okay. So what we'll do is, to get it in exponential form, we will take out the j. J will come here. E to the minus jw13 times 46 sine omega. And so what we have is, in effect, the exponential form. The exponential form. Okay, so let's calculate the norm. The norm of x of omega is equal to the norm of j times the norm of e to the minus jw13. That's equal to 1. That's equal to 1 times the norm of 46 sine w or omega. And so all that is the norm of p of omega, as in the two previous examples. So let's now take the argument. Phase of omega is equal to the phase of j. Really what it is pi over 2. And then we have not plus, but minus 13 omega, which comes from the exponential term. And then we have plus k pi for the p omega term. And that's it. So let's highlight our answers, which is this over here. There's a PDF version of this worksheet in the description. Thanks for watching.